Okay, the last topic for the trigonometry review is a topic related to symmetry. And before talking about symmetry of trig functions, I want to talk about the symmetry of non-trig functions. The definition of odd symmetry for a function f of x has odd symmetry if f of negative x is equal to negative f of x. And I'll describe what these look like in terms of pictures, in terms of graphs. A function has even symmetry if f of negative x is equal to f of positive x. These are the definitions of symmetry. So to test whether a function is positive or negative, you test these properties. You replace the x in the function by negative x and you see what happens. If nothing changes, if you get the original function back without the negative there, then it means the function has even symmetry. If you get the negative of the original function back, then the function has odd symmetry. And if neither thing happen, then the function is said to be neither even nor odd. The function at the top left, the function on the left-hand side, f of x is equal to x squared. We'll check if it's even or odd by replacing the x by negative x. So f of negative x becomes negative x all squared, which is negative x times negative x, which is positive x squared, which is f of x. Thus, f of x equals x squared, f of negative x being equal to f of x means this is an even function. Now, this even function property is manifested in the graph by the graph of an even f of x being mirrored about the line x equals 0. So along this line. It's a mirror image of itself about that line. Okay, the next function, f of x is equal to x cubed. Check its property, if it's even or odd, or maybe it's neither. Let's find out. So f of negative x is negative x cubed, which is negative x times negative x times negative x. 3 negatives will give you a negative. X times x times x gives you x to the power of 3. So we get negative of the original function. Thus, this f of x is odd. Graph is mirrored about x equals 0 and about y equals 0. So it's mirrored twice. First, you mirror it along this line. Now, if you just mirror it about that line, you'll get this. I'll erase it. You get this graph. And then you also mirror about y equals 0. Running out of colors. Let's see. So you then take this graph and mirror it about this line. So you get down there. So, anyways. So that's an odd function. Okay, let's do the next one. F of x is 1 over x. Let's see if that's even or odd. F of negative x is 1 over negative x. Now this minus sign can be brought anywhere you want, including in front. So that's negative f of x. Thus, f of x equals 1 over x is odd. You can see that feature manifested in the graph, that it's reflected about the x-axis and then again reflected about the y-axis. Okay, then last one here, x over x squared plus 1. Let's check if it's even or odd. F of negative x is equal to negative x over negative x all squared plus 1. So you get negative x over x squared plus 1, which is negative f of x plus odd. And again, the graph has that property. It's reflected about the x-axis and reflected about the y-axis. Doubly reflected. Sometimes called anti-symmetric. I'll resist the urge to use that phrase, that term. Now, in the top box are 3 examples of functions that are neither even nor odd. I just want to show you what happens if you attempt to assess their even or oddness by using this method. So f of negative x, we're going to get negative x all squared plus negative x all cubed. So we get x squared minus x cubed, and that's not equal to f of x, and it's not equal to negative f of x. So not even, not odd. It's neither. And the other two, e to the x and x plus 1, would show the same behavior. That's how you test whether a function is even or odd. Now, for the trig functions, we can look at their graphs and determine their symmetry, looking at the graph of the sine function. If you take this, the right-hand side of the function, this part here I'm outlining in blue, and you just mirrored it left and right, you get this. Now, if you take this part and mirror it up and down, you're going to get this part. So the sine graph is an example of an odd function. It's mirrored in both directions. So we would say f of x equals sine of x is odd based on the graph. Thus, f of negative x is equal to negative f of x. Usefulness. This has many types of usage. This is like the silly example for how useful this property is, but it's based on stuff we've already talked about, so I'm going to use it. The sine of negative 7 pi over 6 is the negative of the sine of 7 pi over 6. Is something we can do based on this odd symmetry. So this has nothing to do with the cast rule. This is a secondary method. Not secondary method. This is I don't even want to call it a hack. This is just a consequence of this odd symmetry property, that we now no longer even need to think about the difference between negative angles and positive angles. Anytime you're taking a sine, cos, or tan of a negative or positive angle, you can use the symmetry property to take the minus sign out if there's a minus sign. And now all of your angles are positive angles. You're always going counterclockwise, and that might be a big boost to doing those calculations. Now let's look at the graph of the cosine function. It's only mirrored left and right. So f of x equals cosine of x is even. Also based on the graph. Thus, f of negative x equals f of positive x. Usefulness. Cosine of negative 2 pi over 3 is the same thing as the cos of positive 2 pi over 3. So again, just destroy the negative completely. Don't need to think about clockwise angles. Everything's counterclockwise. Again, and the last one, the tan function. So it might be hard to see. So I'm just going to highlight just part of it. Highlight this part and think, how do we, so the part to the right of 0, how do we reconstruct the part to the left of 0? Well, if we just mirror imaged it, which did a mirror image of that part, we get this, mirror it left and right. So I don't construct the graph, I also have to mirror it up and down. So it's mirrored about x and y. So based on the graph, this is an odd function. Thus, f of negative x. You know, I'm going to rewrite these a little bit of a different way. I'm going to write down sine of negative x is negative sine of x. That's a better way to write that property. Cosine of negative x is positive cosine of x. And then tan of negative x is negative tan of x. Okay. Well, I'm going to add a comment here. Recall that tan of x is sine of x over cosine of x. Sine of x we said was odd. Cos of x we said was even. Odd divided by even is odd, which may have been a property you talked about in a previous math course. Usually grade 11. So I'll add to that comment that odd times odd is even. Odd times even is odd. And even times even is even. And we're going to use symmetry properties quite a bit inside this course. Whenever possible, we're going to try to exploit symmetry and make life easier. Okay, and that's the end of the trig review. Connected to this is a worksheet. I'll post solutions for that.